Hello, everyone. Intense Security Research Summit is now on and live from Tel Aviv. My name is Levi Lazarovitz, and I'm the head of security research at CyberArk Labs.
And I'm Erez Yalon, head of security research at Checkmarks. We're excited to kick off the first ever Intense Security Research Summit. This year, the summit includes about 20 researchers sharing their research, tools, and methods with a specific goal in mind, sharing the research process itself. This is what Intent is all about.
So it might sound a little cliche, but I'll say it anyway. Technology evolves quickly, and the attack surface and attack vectors change rapidly as well. The infrastructure beneath many of the services and apps we use is now hosted by cloud providers, making tenant-hopping vulnerabilities a critical issue. Open source code utilization and the automation of the CI/CD pipeline open up a vast attack surface for supply chain attack vectors and malwares targeting the pipeline. These technologies bring more functionality and more attack surface with them. Attack surface that security researchers and malware researchers should be familiar with to be effective. Getting to know these new techniques and tools that will make you a more effective researcher is what you can expect from this summit. A few months ago, when Erez and I discussed gathering the security research community to share and discuss their new research, tool, methodologies, the idea immediately sparked the concept that evolved to be a summit for all researchers out there, veterans and rookies. A summit where the agenda and the CTF challenges are created by the community itself. A security research Woodstock with researchers on stage. Do you know what I mean, Erez?
Yeah.
So there is so much to learn. In the plan this year, we have a panel led by Erez, focusing on spectacular research failures and what the panelists have learned from them.
I'm really looking forward to that panel. We also have a few sessions about supply chain attacks research, sessions about effective zero-day research, tool demos, and workshops we are sure you'll find insightful and valuable. Checkmarks and CyberArk joined forces here to bring this summit to you. This was done with the much welcome help of our partners, F5, Intezer, Clarity, SentinelOne, and Imperva, that contributed both content and challenges as part of the Intent CTF. We would like to use this stage to thank each researcher and stakeholder who took part. Thank you very much.
The CTF, which included challenges on a broad spectrum of concepts and difficulties, is closed now, and the skill winners will be announced later on today. Still, if you like it, the challenges are available for you to play. So just before we close this introduction session, a few housekeeping notes. The summit agenda will be running chronologically in the virtual hub, so feel free to scroll through and favorite any sessions with the star button to add them to your customized schedule in the Intent Agenda dropdown. You may join each session 15 minutes before it begins. And don't worry if you miss one. About an hour after each session is over, it will be available on demand. So just scroll to the bottom of the page, and they will be categorized by session type. Lastly, feel free to submit your question during each session to the speakers via the Q&A chat box. They look forward to interacting with you.
And now, without further ado, I would like to warmly welcome Alyssa Miller, the Duchess of Hackington. With more than 15 years as a hacker and a security researcher, Alyssa is the Business Information Security Officer at S&P Global Ratings. And she has some messages for all of us in the security industry. Alyssa, the stage is yours.
Hello, everyone. Welcome to the Intent Summit. I am super excited to be here with you today. My name is Alyssa Miller. I am the Business Information Security Officer for S&P Global Ratings. Now, if you find yourself asking what in the world is a Business Information Security Officer or a BISO, good news is we're going to get there. Give me a little time. We're going to talk for a little bit. We're going to share some stories. We're going to have all sorts of fun. But we'll get there, and I'll talk to you about what a BISO is and how a BISO can help you bring security in as a business function. Now, for security researchers, I know that kind of sounds like, wow, that's a really corporate topic, but trust me, we're going to get there. You're going to understand why this applies to each and every one of us in the security community, regardless of what we're doing for our community. Me personally, I've been a hacker all my life. I mean, I was the 12-year-old who bought her own computer, and I used it pretty quickly to hack into online services and so forth. And I've been doing it ever since. I was a programmer. I I was a pen tester. I've been through all sorts of different security roles over the last 16 years. So we're going to dive into this. But first, I want to just start by telling you a little bit about my kid. All right. So I've got 3 kids. My youngest was getting ready to drive a couple years ago. And, he comes to me and he wants to get a car. He's going to get his driver's license. He wants his own car. And, he comes to me, he says, hey, I found the car. It's this 2014 Mustang GT, and he's all super excited because it's, it's only $7,000. And of course, imagine the look on his face. We've all been there, right? When I tell him, nah, I don't think you're getting that. I think you're getting this 2007 Toyota Camry instead. He had all these dreams. He wanted to go fast. He wanted the cool car. He wanted it to be awesome. And what did I do? I kind of shut him down. I give up. Sorry, no, you're going to be driving this boring car because it's safe. And I don't know that you would be safe in that Mustang. I want to make sure that you've got something we can trust. And so, we've all been there as kids. You remember what that was like when, your parents didn't really want to buy you the cool, awesome car that all your friends were going to be wowed by. And instead, you drove some boring family mobile or something like that. So, I think about this in terms of what do we do as security people? We've got devs, we've got businesses who want to go really fast. They want the cool car. They want all the cool new technologies. And there's security. We stand there and we say, nope, you're getting that Camry. That's the best you're going to do. Sorry. And I started to think about what can we do better? So let me share this with you. This is my car. All right. I've been driving for a few more years than my son. So I can get into this car. And I love it. This was probably my favorite pandemic purchase. I bought this last year. I was really excited. It's a 2017 BMW 340i with the M Performance package. So for those of you that don't know, we're talking like 350, 360 horsepower, about equal foot-pounds of torque. The thing is a monster, right? It's fast. It'll blow the doors off of that 5.0 Mustang my son was looking at. It's a super fun car to drive, and I love the heck out of it. But you know what else? It was also a 2017 top safety pick. So not only is this car fast and fun to drive and super exciting to be behind the wheel of, it's also a safe car. If I get into a crash in this car, I can trust it to keep me safe. And so when I think about security, it's like, that's kind of what we need to be doing, right? I mean, let's think about that. Imagine our businesses want to go faster and faster. They want all the cool technology. And instead of being there telling them, no, you can't have it, we need to be the ones telling them, yes, here's how you can have it. And here's how you can be safe using it. That's what security research is all about. As all these new technologies come up, as all these new exciting applications and Internet of Things devices and whatnot come out, and we see all these new innovations, we as security, we're the ones that are trying to help them understand how can they leverage those cool new technologies in the safest way possible. That's where security lies. Because let's look at the past. Let's spend a little time with some, kind of useless, but maybe important security trivia. Do you see this guy? That's Alan Scherer. Does anyone know who Alan Scherer is? Well, let me start with this. Do you know who and what was the first password protected system? It was at MIT in 1961. In November of 1961, they released the CTSS, or the Compatible Time Sharing System. They took an IBM mainframe and said, this is silly that only one person can use it at a time. How can we set this up so multiple people can make use of it? And so they came up with this compatible time sharing system. Now, what they did was they added in controls that each user was only allowed 4 hours a day to use the system, because they still had limited resources. We can't just let everybody go all day long on this thing. And so that's how they implemented it, was they created passwords. Well, Alan Scherer decided that he wanted more than his 4 hours. And so, now remember, I said November 1961, they created this password protected system. In March of 1962, Alan Scherer figured out how to print off the password file. and he started accessing the system using other people's passwords. But he was also smart, and he distributed those user ID and password combinations to a bunch of his friends and classmates so that it was harder for them to figure out who had done this. So that's our first ever password hack 5 months after the first password system was introduced. Now this one you might be a little more familiar with if you didn't know the last one. This is the Morris worm. Some of you might remember this story. In November 1988, this worm was created by Robert Morris, and he released it, again, to MIT. I don't know why MIT keeps getting picked on. And the point of the worm was he exploited multiple Unix vulnerabilities and wanted to show that, hey, look, this is what I could do. And he set up this worm to self-propagate. And so what it would do, though, is it would go to each system and it would check to see if it was already there. And if it was already an infected system, it moved on. Well, he was worried that people might discover this worm and try to prevent it by having the system return a false positive to the system level checks that he was doing. So he set it up that for every 14th attempt, it would just replicate no matter what. Well, the problem was very quickly this turned into multiple infections on the same machines over and over again. Before he knew it, it was DOSing each of those machines. So that one little no forethought, that turned into the Morris worm. So that's a really popular story of kind of the first computer virus. And, now we fast forward again. We're in 2013 and then 2014. You know what happened then? The world's largest data breach to date. Yahoo was breached not once, but twice over the course of those years. They first announced it in 2016. They didn't tell us the full details until 2017, but it turns out all 3 billion of their users had their credentials exposed. So what does all this mean? How can we fight back against this? What can we do about this? Well, the security industry, for its part, has created this whole mess, right? If you're a security vendor, I apologize. I love you all, and I know that some of them are our organizers here today. I've worked for security vendors as well. There's a lot of great products, but there's so many of them because this is such a complex world. Gartner estimates that by next year, we're going to be spending over $170 billion globally on cybersecurity solutions like this. $170 billion. A few years ago, that was just over $100 billion. So we can see that it's accelerating. It's continuing to grow. We've got all these cool tools. Each one of them is kind of specialized. You see in that graphic, infrastructure security, endpoint security, managed service providers. We see messaging security, specialized threat analysis and protection, risk and compliance, identity and access management, all of those domains where we want tooling that helps us secure our systems. So how's that going? Well, if you've been watching the headlines, you know the answer. Maybe not so well. Data breaches are still in the news on a weekly basis. Now ransomware has taken over, and especially in the last 2 years, ransomware is the #1 threat that we face in cybersecurity. Ransomware is exploiting vulnerabilities, and those vulnerabilities exist in many places. Sometimes they're technological vulnerabilities. Other times they're people vulnerabilities. We're using phishing schemes to attack users and to get them to give up details that allow for the expansion of ransomware attacks. Sometimes it's a combination of the two. But this is where security researchers come into play. This is where we have the ability to change the landscape, where we can highlight whether we're social engineers, whether we're pen testers, we're red teamers, whether we just kind of do this as our own hobby, digging into our technology and really trying to understand it is the role that we play in highlighting the security struggles that we face, sharing that information with those that create this technology, those that are using this technology, so that we can all be a little safer. A colleague of mine, Karen Al-Azhari, gave her famous TEDx talk a number of years ago, where she talks about hackers as the immune system for the internet. We have this huge World Wide Web. Wow, there's a term we haven't heard in years, right? this huge worldwide web of all these interconnected networks and computers and, oh my gosh, IoT devices, mobile phones, everything else that we use that now connects to Wi-Fi and connect to our networks. And they talk across the internet and they share information and they transmit information. They create all of this exciting, cool, new functionality that we have in our world. Things that we don't think we could live without. But as we've seen over and over again, with every new technology come new threats. And when you sit and listen to Karen talk, and indeed this is the reality for all of us, as that digital infrastructure becomes more and more just inherent to our way of life, it's hackers, it's security researchers, it's those of us out there on the front lines who dig into that technology with all of our creativity to really understand how it works. We're the ones that serve as the immune system. We're the ones that serve out there to identify where the infections are happening and how we can do something about it to make our world and our way of life just a little bit safer tomorrow than it is today. This is why security research is so important. So what happens? We dive in, we start digging in, we conduct our pen tests, our network assessments, we do all the different things that we do. But what do we start to discover? A few years ago, I was working at CDW. I led our information security solutions practice. And I did some research into the pen tests that we were doing out of that practice. And what I found were, when I looked at the top vulnerability themes, 40% of the vulnerabilities that we identified in the pen test for our clients were configuration management. These are things where the technology was already there to make that system safe, but because of some configuration issue, be it a public S3 bucket, an unencrypted data store, insecure encryption algorithms, passwords that weren't hashed on databases, all the things that are like simple configurations where you just flip a switch. Those were the vast majority of the vulnerabilities we are identifying. 13% more than the next closest, which was account management, and that was issues around users. So I saw this, I thought, wow, this is really interesting. I wonder how that looks historically. So I did a little more research. And look at this, look at the trend line, the dotted line here. That's the trend for what I found over the course of 3 subsequent years. 12 quarters of statistics and an absolutely flat trend line at 40%. What does this tell us? This tells us that, well, yes, the technological vulnerabilities can be an issue. It's actually our use and our knowledge of how to be safe with those technologies that becomes so crucial. So we as security researchers, we're doing as much to find, the cool 0 days in that new web-connected camera system or refrigerator. Those are great. But a lot of the time what we're finding are those common issues that businesses and consumers and organizations are making on a daily basis when they implement those technologies. And technology is constantly expanding. We're constantly looking for ways to accelerate this, make this faster and faster. What about when we look at some of that infrastructure? We have this idea of infrastructure as code, and we're letting developers be more and more responsible. And they're using things like containers to deploy. And the whole idea with containers was, well, we can use these base images, right? We can use base images. They're going to help make us safer. Well, what happens with these base images? I worked for Sneak for a while. I did the research and was responsible for writing our State of Open Source Security report in 2020. And one of the things I looked at were the number of vulnerabilities that we discovered in the latest image in Docker Hub. So these are common. These are the top most popular base images in Docker Hub for 2018 and 2019. And you can see the number of known vulnerabilities that exist. Now, you see the node image in particular is like the outlier here. Like that one's really, really bad. And that's partially because it was based on a version of Debian that, I mean, if you use Debian, you know how they are about releasing updates. and it was a very vulnerable version. But don't let those really big bars distract you from some of these others. 78 vulnerabilities in Postgres, 83 in the Nginx image, 55 even in MongoDB. Ubuntu is the only one who got really good. Like, they went from 30 down to 0. So, but that could also be that it was a pretty new image, and so a lot of the vulnerabilities hadn't been discovered yet. So these are things that we're also helping as security researchers, as pen testers. These are the things we're trying to help address. But what happens when we try to bring security into the development lifecycle? How do we do that, right? So traditionally, the approach has been something like this. We have our phases of the development lifecycle. We used to call it the SDLC, right? The software development lifecycle. Then we realized, well, there's more to it and some other changes happened. So we've kind of changed. But somewhere along the way, there was this pipeline of how we develop software. Starts with the backlog, and then we get done. That's where our user stories sit, and we know all the feature requests we want. We're going to take that. We do some sprint planning, then we move into coding and committing. So now we're writing code, and we're committing it to a repository. And then we end that phase, and we move from that phase into building and testing. Now we've checked that code in. We're going to build it. Once we built it, we'll pass it off to QA, and QA is going to do all their stuff with it. Then when QA is done, and they say, hey, you're all set to go. You've promoted up through all the levels of repository, or we're ready to go to deployment. Now we go to the deployment phase, and we deploy that software, and that involves all our change management processes and everything else. And then we move into that post-deployment phase, or that monitoring phase. So when we look at that from a security perspective, our traditional approach was this. We saw those transition points between the phases of the development pipeline, and we said, well, we're just going to inject gates. We're going to put gates in here. We're going to put these quality gates. We're going to say, we're stopping you here, and you can't progress to that next phase until we open the gate and say it's okay. So maybe going from the backlog into coding, we're going to do threat modeling first. We're going to look at your whole big system diagram. We're going to create data flow diagrams. We're going to identify all the vulnerability or all the threats. We're going to classify them according to stride, and we're going to do all that stuff. And then when we get done with that, then you can start coding. Oh, and then when you get done with coding, well, now we're going to run our SAS tools, our code scans. We're going to run our, maybe we're really good at this, and we've got software composition analysis, and we're looking at that too to try to figure out, what libraries you've included that might have vulnerabilities. So, okay, we're going to do all that. And when that's all done and you've met an acceptable level of security, great, we'll move you on. And this goes on down the line. We have always done things this way in security when it came to software development. This is the story of AppSec for as long as I have been in technology. 10 years as a developer, 16 years as a security practitioner. We've always thought this way. The problem with this thinking, though, is it's so 2008. Think about that. Why am I talking about 2008? What in the world? Alyssa, what happened in 2000? What's going on with 2008? Some of you might know what happened in 2008. You see, in 2008, Andrew Schaefer and Patrick Dubois got together and had this really cool idea. They wanted to figure out, how can we remove the friction from our development processes? How can we get our developers and our operations people working together toward a shared responsibility to deploy that software? How can we make them all responsible for making sure that that development pipeline is quick? And what did they call it? They called it DevOps. 2009, the first DevOps Days was hosted. That's our first understanding of the idea of DevOps. Now, we as security practitioners, it took us a few years to catch up. In 2012, Gene Kim and Josh Corman did what is kind of their now pretty famous talk at RSA, talking about security is dead, long live rugged DevOps. And it was all about this. It was all about, how do we inject security? How is security as we know it completely different? How do we have to completely adjust? And yet, for years and years and years following that talk in 2012, and indeed to this day, when I go to conferences and I listen to people from security talk about how are we going to make DevOps more secure, the first thing they talk about are gates. Now, the problem with this is, look at this. This is an infinity loop. The whole point of DevOps is, and especially if we're doing CI/CD, where we're now talking like continuous integration, continuous deployment, this thing doesn't move backward, right? It moves in one direction and it just keeps flowing. It's that over and over, that repeating cycle. So what happens is when we put these gates in here, we threaten to gum up the works. We threaten to push the pipeline backward. We say if you hit this, you're moving from code and commit into build and test, and we're going to do SAST. And if our code scanners find too many vulnerabilities, we're going to push you back into coding again. We just broke that pipeline. In fact, we call it that. We call it breaking the build, right? Have you heard that term before? This is not compatible with DevOps. This is why security still kind of gets shunned from, hey, we want to be a part of your development pipeline. Let us make you more secure. And then we get worse. We get kind of almost arrogant and we say, well, yeah, you're right. DevOps is all about shared responsibility. So security is everybody's responsibility. What about our responsibility to make as part of that? If we're in security and we're saying shared responsibility, sure, they're responsible to make their software secure, but we're responsible to make their deployments faster, to make their pipelines more efficient, to make sure that when things get deployed, it's stable. That becomes our responsibility if we're going to say we want to be a part of the shared responsibility culture that is DevOps. So how do we deal with this? We got to get rid of those gates. We need to move to this model where our security practices become inherent parts of those phases in the development pipeline. We can't be the thing that pushes backward. We can't be the thing that threatens to break the pipeline. We have to be a part, integral to each of those phases, bringing tools and processes that fit right in. That's how we start to move forward. And as researchers, this is something that we can start leading the way with. So I love this study. And I know a lot of these dates are kind of a little bit old. 2020 was a bad year. We didn't get a lot of really cool research, but a lot of this stuff came up at the end of 2019. CircleCI and Puppet put together their State of DevOps report. And I love what they did here. They mapped the frequency with which we conduct certain security practices against the importance in terms of strengthening the security posture of each of those activities. So you see on the y-axis how often we conduct them. You see on the x-axis how much of an impact they have. And I know it's maybe a little hard to see on your screen, but in the upper left, we see all the traditional security things: static code analysis, pen testing, dependency checkers, security requirements. We do these a lot, but they don't have a lot of impact on security posture. Instead, when I look down here, what I see are a lot of things that talk about collaboration. Security and development teams collaborating on threat models is that one you see farthest to the right. But I also see things like security personnel reviewing and approving code changes before deployment. I see security experts evaluating automated tests. Security tools integrated into dev ecosystems. That's the big one there at the top, second farthest to the right. Bringing security to them where they live. Suddenly we start to remove the friction, we start to remove those gates, and we become a part of their process. But how do we get them to buy into this? How do we get them to accept this and to adopt this? How do we help them see? Because we all know when you talk to devs, they don't want to do security, they just want to code all day, right? Wrong. Yes, they would like to code all day, but how many of you have sat down and talked to a developer? I have yet to meet the developer who doesn't take a certain level of pride in the software that they create, in the products that they create. And they generally are kind of offended if, say, somebody breaks into that, exposes a flaw in it, because that speaks to the quality of their code. But yet, we still need to motivate them. We still want to bring that closer. So how do we start to make this happen? Well, let's start with that thing that's farthest to the right. The thing that's going to have the most impact. That thing that focuses on collaboration. It's threat modeling. Now in 2020, I do know what year it is, 15 security researchers, myself included, some other names that you might recognize if you're familiar with threat modeling, people like Adam Shostak, Izar Chandic, Zoe Braderman. We all got together and we started talking about threat modeling. Because you see, threat modeling is this thing that we have a hard time adopting in DevOps. Developers look at it, they think of things like what I talked about before, Stride and Dread and Octave, and all these things are really heavy hitting. And we think about them in terms of this big process where we get a big architecture diagram together as part of the design cycle. And then we talk it through and we identify where data flows and where there's trust boundaries. And we try to identify all of that. And we that's a long, hard, difficult process. It ends up being that gate before we can start deploying or even start developing the software that we want. And so we wanted to figure out, how do we do this different? How do we get to a point that we can help people implement threat modeling no matter what it is that they do, no matter what paradigm they follow? How can we make this happen? And what we came up with was the Threat Modeling Manifesto. I encourage you to check this out. It's open source. You can access it at the at the URL there. But the big thing was, our goal was not to create yet another framework, not to create yet another methodology, but instead to inform people, how do you build a methodology that fits within your organization, that fits your current processes? And so that's what we wrote in the manifesto. Now, when I talk threat modeling, you saw already what Circle CI and Puppet found. Like, they looked at it and they said, wow, this is a thing that really impacts our security posture. And what I'm going to tell you is threat modeling is that thing that you can use to actually excite your developers, because I'm going to show you in a second how threat modeling can make the development pipeline faster. You heard me. I said it. Yes, security actually making things faster in development. Like, whoa. So here we go. We're giving them the fast car, but we're showing them how to use that fast car in a safe fashion. So we're not giving them the Mustang necessarily. We're giving them the fast car that is also the top safety pick. So what have we been talking about in AppSec for years and years and years? Probably as long as I can remember. We've been talking about this idea of pushing left. How do we get security earlier in the life cycle? Well, where's the earliest you can go with your security practice? What's the earliest point in that whole development pipeline? It's the backlog. It's the user story. So what if we simply brought threat modeling to the user story? Think about what this does for you in your DevOps world. No longer do you need a big design cycle, because you're not going to threat model the whole design of the entire system. You're going to take just that user story, and you're going to look at just the scope of that user story, and you're going to talk about the threats that are in it. Now, do I need a whole big meeting with a whole bunch of people involved? Maybe, but maybe not. Who writes your user stories most often? It's probably a business person who has a really good understanding of what the critical assets are that are involved in that user story. Maybe it's that it's a critical function that has to always be available. Maybe it's a certain kind of data that gets processed by that user story. Maybe it's something else. But they're the ones who really understand what's important to the business in terms of what that user story does. So what if we have them identify those assets, and then in plain language, forget about Stride, Octave, any of those weird frameworks we created for threat modeling that require security practitioners who've been trained in that to come in and do it. No, instead, what if they just in plain language talk about, gee, there's a threat that this particular piece of data might be stolen, or a threat that this particular piece of data might be exposed. There's a threat that, someone might try to make the system unavailable and impact this critical functionality. Put that information in the user story, because at the end of the day, the goal of threat modeling is just to give us that information so our developers understand what the threats are, so they can design countermeasures to address those. So now if we put all that information into the user story, we take all that threat info, just in plain language, you put it into the user story. Now what happens when your devs take that off of the backlog and they're going to start that development? Now, it might be that you do sprint planning. Maybe you're a little more in the agile camp and you actually have formal sprint planning. Maybe you're full on CI/CD and they're just grabbing the next story, next highest priority story, and they're going to go and develop that. Either way, there's some level of planning that goes on. Maybe it's in their head, maybe it's a little more detailed. But at this point, because they have that threat information, they can take that information, they can understand the security requirements. If you're really advanced, they might even have reference architectures that they can leverage for how to implement certain security controls that would address those security requirements. Maybe not. Doesn't matter. The point is you're giving them more information than they had before. Now they can take that information, and that information helps them build security controls. So it's pointed them already in the right direction. If they've got those reference architectures, they can go grab it, they can implement it, they're done. They don't even have to think about it again. If they need to build it, hey, at least they know what it is that they have to build. They don't have to worry about cycling back and forth 5 times. They can build those security controls. They can work with their security team, or maybe you even have security champions embedded in those teams that can help bring that information, help contextualize it, help them design those security controls. But then think about this for a moment. You now know what those security controls are that address those critical threats and protect those critical assets. What if we took that and say, in that developer world where we're doing infrastructure as code and things like YAML have been, really important to developers? What if we create some simple YAML language that they can take those security controls and document them in YAML and then pass that on to our QA team, who can now automate test cases that focus on and prioritize the most critical assets within that particular user story and test for the most critical, highest priority threats, making sure that those crucial security controls are working. Well, and if I can do that now in the QA in that testing process, well, can't I float that to the next phase? What about monitoring when we've deployed? As we move into that deploy and post-deploy, hand that YAML over to my SREs. Have the SREs use that to automate their monitoring. They now understand the types of threats they need to be looking for. All of this flows with a great degree of automation, and we have things prepared. Suddenly now our development pipeline gets faster. So imagine if as a security researcher, you can start to be a part of this process. Now, this doesn't replace pen testing. It doesn't replace all those other activities that we want to plug into these phases, but it helps us make what we do more integral to each of these phases rather than that gate in between. And more importantly, it starts to demonstrate how security can be valuable to the business in ways other than just some ethereal, hey, we're going to protect you from this threat or this risk, which, yeah, it sounds great to us, but at the end of the day, that's using fear, uncertainty, and doubt to try to drive people to do the things we want them to do. And you know what? That doesn't work. Why doesn't it work? Well, let me give you a little lesson in neuroscience. There's been a lot of studies in neuroscience about how motivation works. And what we found is that if I want to discourage someone from taking action, I want a child to stay away from a hot stove, I want a person who can't swim to stay out of the water. The best way to encourage that, or to discourage those actions rather, is through threats and fear. Tell that person you could drown if you go in the water. Tell that child you could burn your hand and have to go to the hospital if you touch that hot stove. That's the best way to discourage action. But we in security, we're not trying to discourage action. So when we come to the plate and we say, hey, all of these bad things are going to happen if you create bad code, that's not encouraging them to act. That's encouraging them to run away. It's a fight or flight response. And the reality is we're encouraging the flight. They're going to run away. They're going to ignore us. They don't want to listen to threats. But what neuroscience has found is that if I want to encourage action, the best thing I can do is offer some form of reward. So if I'm trying to influence people, maybe somebody whose product is got vulnerabilities that I've discovered, or users who I'm trying to influence to not click on phishing emails, instead of threatening them with, you're going to have to go to security training if you don't do this, or, the bad guys are going to hack into your website or your app and they're going to expose all your users' data. Yes, that's important context. But that shouldn't be the message you lead with. How can you leverage that differently? To give you some idea of what neuroscience has done in this, there was a study by SUNY a number of years back, or SUNY, if you live in New York, you know that that's kind of how we typically pronounce that. They looked at a hospital. They went to North Shore University Hospital. You see, North Shore was having some trouble with infections. And for anybody who's worked in the medical field, you know, one of the most basic things that impacts infection rates in medical facilities is hand washing. Good hand washing hygiene significantly reduces the potential for infection. So North Shore University Hospital is having some problems. They want to figure out if people are washing. And so they found that their numbers were abysmal. They were about 10% compliance. So the first thing they did was they went through all this training, and they warned people about disciplinary action if you don't wash your hands, and then they installed cameras at every hand washing station. The employees knew the cameras were there. They knew the penalties if they didn't wash their hands each time they entered and left a room. The compliance didn't improve. It was still in that 10 to 15% range. So then they changed things. Now, along with the camera, they installed little signs, little marquees. And all the marquees did was, after somebody washed their hands, it popped up a message, said, way to go, or some kind of encouraging message, said, good for you, thanks for remembering to wash your hands, whatever. That little bit of encouragement increased their numbers from 15% compliance to over 90%. It's uncanny, just that little reward. So how can we use that in security? How can we do that same thing to get those kinds of numbers? This is where the BISO can help you. So if you read the abstract for this keynote, I told you I was going to talk about the BISO because I'm a BISO. And I think that my role is particularly valuable. And I think we as security researchers want to start thinking like a BISO as we try to influence those businesses that we're working with every day. So let's start with, what the heck is a BISO? So typically in most organizations, you might be familiar with this. You've got a business line over here, you've got the information security team here, and you have this cavernous divide between the two. They don't like to talk to each other. They're adversarial in their relationships. It's just not a friendly thing. So what does the BISO do? The BISO comes in and builds a bridge between the two. Now the BISO, unlike a CISO, is not a separate organization. As the Business Information Security Officer, I don't report to the CISO. I actually report into the business. I am part of a division. I lead the security strategy for our entire division, and I report to the divisional CTO. Now, why is that important? Because that bridge needs to be two ways. It's not just about advocating within the business that they do security things. It's also about advocating on the part of the business when I talk to the security team. How do we get security initiatives to align with what the business is doing? How do I demonstrate how this security initiative is going to be of value to the business? Because here at the end of the day, when you stop talking in security terms, when you stop talking in terms of FUD and threats and risk management, and focus on the things that matter to the business, and you connect what you're doing from a security perspective, or what you want them to do from a security perspective, to the priorities of the business itself, suddenly you get more traction. So how do we start thinking like a BISO? Well, we have to think about those motivations. What do they care about most? The first is profitability, of course. So how can your security steps, how can your security practices, how can your security initiatives help make them more profitable? How can it save them money? Look for the ways that it can do that and present those. Present what you're asking them to do from a security perspective in light of how it's going to save them money. Or how is it going to help them in terms of innovation? How is it going to make them able to leverage new technologies in a safe way, to build a fast car that's also safe? Show them that. Bring that context to your discoveries, to the things that you're seeing, to what you want to influence them to do. And then there's this whole idea of agility. How do we make sure that our products are agile, that we can move quick, we can leverage our DevOps and CI/CD pipelines, our product development to be faster and to respond to our user needs? And how does security enable that? I showed you one example. But think about in terms of how does this thing I'm asking you to do, how's that going to make you more agile, make your products better, enable you to bring them to market faster? And speaking of the market, how can you use that security as a competitive advantage? How does it improve your overall position in the market? How does it make your business model more sustainable? When we focus on these things as we talk to people who are not security practitioners and researchers, this is how we motivate them. Speak about your security ideas, those remediations in terms of their motivations. Give them that reward, that carrot. Put it out there. Hey, you can do this if you do this. Or doing this security thing will make you able to leverage this technology faster, quicker, safer. Focus on those elements and bring that message to the table. That's what we need to be doing. That's the future of security research. We can't just talk about the security technical jargon anymore. We have to understand that if we actually want to share information, we need to share it in a way that's meaningful to the people that we're trying to convey that information to. So it's just about time for me to wrap up. I'm going to leave you with this quote. This quote is from John C. Maxwell. He says, "Nobody can motivate themselves in a positive direction by continually using negative words. So stop talking about the FUD. Stop talking about the horribly bad, awful things that are going to happen. Let's talk about the good that will come from those security practices that we're advocating. Let's talk about things that are exciting to the business. Let's look for the ways to give them a fast car that will also keep them safe. They don't need the Mustang. They don't need the Camry. Get them into that super fun, super exciting, super awesome car that also is going to protect them when things go wrong." Finally, I invite all of you, continue the conversation. Reach out to me on social media. I'm always happy to talk about your ideas, share more with you about what this weird thing is that I do. It's called a BISO. I do other talks on that. You can go to my website. You can see those talks. You can contact me there. My blog is there, so I've got some information there too about the role. All of these ideas you're hearing about are things that I talk about all the time. So I invite you to check that out. Check me out on LinkedIn. Twitter is by far the easiest way to get in touch with me, though. I'm more active on Twitter than any of these other things. So by far, I invite you to join me there. And then finally, great big thank you. Thank you to all the organizers for the Intent Summit. Big thank you to my employer, S&P Global Ratings, for making it possible for me to even be here today. And most importantly, thank all of you for tuning in, for being a part of the summit. Remember everything we've talked about as you go through the rest of this day and you hear all the various talks, all the different ideas, all the different technologies that you're going to hear about today, all the different research and all the exciting stuff that we're doing with technology. Remember in each of those moments to think about, all right, how do I show this in terms of the fast car that's also safe? Thank you so much. Take care, and we'll see you all again real soon.
Hello, everyone, and welcome to our panel. While everyone is talking about wins and success, we will rain on the research parade and talk about failures. With me today are 4 panelists, friends from our security research community. If you want to address any question to any of them, feel free to type them in the chat. So, thank you for joining me. I will let each of you to introduce yourself. Let's start with Irena.
Thanks. Hi, my name is Irena Adamski. I am Director of Research for Cortex XDR at Palo Alto Networks. I'm also a co-organizer for the B-Sides Tel Aviv conference, and I'm happy to be here. Thanks for having me.
Thank you for being here. Eran?
I'm a security researcher at CyberArk. I primarily focus on local privilege escalation bugs and on drinking cocktails. And there is a strong correlation between the two. The more I drink, the less bugs I find.
Excellent. Sounds good. Ari?
Hello, my name is Ari Eitan. I'm the VP of Research at Intezer, and I'm specializing in malware analysis and reverse engineering. And it's a pleasure to be here.
Good to have you. And last but not least, Sharon.
Yeah, my name is Sharon Brzezinov. I'm a vulnerability research team at Clarity. We're doing mostly research on SCADA devices, equipment, PLCs, HMIs, and we're trying to find vulnerabilities and disclose them to the SCADA vendors.
So this awesome panel is going to talk about failures, screw-ups, problems, all the things that we sometimes a bit timid about bringing out in the spotlight. I think the reason the four of you are here is because you maybe want to share with us some interesting stories, maybe things that we can learn from. And I think that I would like to know why it is so important to you, Irena, for example, to actually share not only the success stories that you see on a daily basis, but also the failures.
So I think that our math teachers at high school summarized it best. Basically, the most important thing is not just the final answer to the question, but also how you get there. Because the final answer might not be the exact correct number, but along the way you get all the different steps, and you might have like the wrong turn, and then you take the right turn and the wrong turn again.
So you're talking about the process.
The process itself
of the research maybe, and not necessarily the outcome of a great, I don't know, zero-day vulnerability, whatever.
Exactly. Along the way, you'll find, you'll eventually get there.
Okay.
But you'll learn along the way a lot of stuff.
Yeah.
So it's very important.
Interesting. So Sharon, what is your take on that? Why exactly do we think that we do want to actually share these failures?
Yeah, so the way I look at it is how I consume research information. So I mostly go to Reddit NetSec or some kind of Twitter accounts and read all this kind of research publications that other great researchers are publishing. And you'll never find any failure of anyone publishing big-wise. I failed. I tried to do that, but I failed. I could not achieve what I wanted. It's like the survivorship bias that every research that you read is a success story, and you'll never find failures. But failures are there. We know that. I know that because I fail on a daily basis, but I learn from this. I learn what not to do next. And I think it's very important to share all these failures so others could learn and not repeat on the same mistakes.
Interesting. So you're talking about the survivor bias here. What you're trying to say is we see all these success stories, but it doesn't mean that there are no failures.
Exactly.
Right? Underneath the surface of this aura of success, of constant success. So if it's so beneficial to share these stories, these failure stories, or the painful mistakes that we do, why is it so easy for us to not publish or sometimes even actively hide them, maybe? Ari?
Yeah. That's a very good question, actually. I think it could be a bit embarrassing, to share the fact that you failed. Although, as Sharon said, we failed on a daily basis. It's part of the job, But the security researcher community is an amazing community, but it's very demanding. And, to have your professional skills is maybe the basic. And if you're not sharing that and you share your failures, maybe you could feel that something is not okay with you. But again, we do it on a daily basis. That's part of the job. And once we'll put it on the table and it will be legit to talk about your failures, they are no longer failures, right? You make it a success story by sharing it. So,
okay, Eran, what do you think? Why do we hide our failures as a go-to strategy?
It's a very human thing to hide our failures, and I strongly think it's a mistake. It's very beneficial for us to admit our so-called past mistakes and failures because we grow from that. Also, companies not just as personnel, like, for instance, Apple in the 90s developed over 100 different products. And when Steve Jobs got back, he decided to only continue with 4 of them. And then the company had major success stories because of that. You need to bury the old ideas to help you gain more focus on the good ideas.
Okay. So the question is, by burying the old ideas, the bad ideas, aren't we missing something from learning from them?
No, because when you do it, you need to do a proper burial ceremony. You need to understand what led you to this thing and to do almost like a funeral for your own ideas, and even you can put them on a wall. Yeah.
Yeah, you need to
Post-mortem.
do like post-mortem
Post-mortem.
analysis,
Classic postmortem.
7 days of Shiva, have
completely.
friends come over,
And-
food, drinks.
And for my story, I can tell you that I had some times that I investigated something for a couple of months, and then I needed to kill it, to say goodbye to it. And it's difficult on the
Okay.
personal level.
So I think that's an excellent segue to start the section of this discussion where everyone is here to join us and to hear your failures and the way you show them proudly. So Eran, you started to talk about a failure. Go
Okay,
with
I'll start out with a glorious one. In my work, I primarily focus on finding local privilege escalation bugs. And your base assumption when you do this kind of research that you start from a limited or low privilege user. And this time I was working on Windows, so I was investigating a driver, which is a perfect place to look for bugs. So on Windows, you communicate with a driver through a thing called a device object, not directly to the driver, and it has permissions that say if you can open a handle to it, and you communicate to it through the handle. So the first thing that you need to do is to understand if you can get a handle to it. Then I got it, said to myself, great, let's look it up and kick it in IDA. So I was reverse engineering the driver, and after around 1 hour, I found a bug that crashed the kernel. I got a blue screen, and I thought to myself, wow, great, let's continue.
We're getting somewhere.
Yeah, we're getting somewhere. After 2 hours, I found 2 extremely powerful primitives like read, write, where in the kernel. So those are the ultimate primitives that you want as a security researcher to find in the kernel. So I developed the exploit for 1 week or so, feeling pretty good to myself. I launched it and I got a system shell, thinking to myself, wow, I'm a great researcher. So I did the responsible thing and reported it to the vendor. After 2 weeks, I get an email saying, wow, it looks very interesting, but we have some hard time running your exploit. For some reason, we get an error code of 5. And if you're familiar in error code in Windows, 5 means access denied. So I thought to myself, wait a second, what happened? I reran the exploit on my guest machine, and I got the same error. And then I said to myself, oh, no. I looked at the first function in my exploit code, and it was a create file to get the handle of the device, and I got an access denied. Then I understand to myself that I did all those things, all the re-execution of the exploit from an administrator shell.
Oh, no. Oh, no.
Yeah, so the TLDR of the story is that I found very cool bugs in the kernels, but I did it from an administrator standpoint, so they do not
So
count.
that is clearly an error that was your fault,
Completely
right?
my fault.
Okay, so maybe we don't need to talk in faults, but your responsibility, let's say that.
It's my responsibility, but from attacker's standpoint, or if you're a red teamer, those bugs are still
Yeah,
useful.
of course. Okay, so this is the topic of how we shoot our own foot, right? So let's have another example like that. Ari, maybe you have something that you managed to create your own failure?
Yeah, so it's kind of a bug that we had in the methodology research. At Intercell, we're focusing on malware analysis, and once in a while we get this new sample that we would like to investigate, and we discovered this, what seems to be a very interesting ransomware sample. No other vendor could detect it in VT, and we started to dive in, and it looks interesting. So we're digging more and more, and eventually we decided that it's interesting enough to write something about it. And then we started the writing process. We created a blog and so on, POC, but we took the time to be honest. It wasn't like full gas. We took it easy. And then we reached the marketing team, right? And we were like, hey, we have this interesting story. Maybe we should reach reporters and so on.
Yeah, let's go. Let's blow off the media, PR, everything.
This is
right?
it. This is what we've been
Because
waiting
this is the
for.
process. This is what we do.
Exactly.
If you don't blog about it, it didn't happen.
If
Right.
don't
You need
blog,
to share the
You need
Exactly.
to share
With the
malware,
community.
otherwise you didn't do
Obviously.
security research.
We have this interesting finding. We want to share it. There's no point of having intel and keep it to yourself.
marketing are happy already.
If marketing are happy, then we are happy. Long story short, we scheduled the publication for a certain day, and 2 hours before the launch, another vendor published about this specific
Oh,
sample
no.
with a different name. They named it differently, and they basically took all the focus.
The exact
almost-
same thing.
The exact same sample. It was amazing, right? And I really take the responsibility to myself, since I know that we didn't. It wasn't in super rush. Like,
Yeah, you took your time.
yeah, we took the time,
And
we
why
learned
was the
from it.
reason you took your time? Because
I thought, what are the chances that another
what are the
vendor
odds?
is working?
Yeah, what are the odds?
I have a story about that. So we have a similar story. So we also had this amazing campaign we were researching. Like, we didn't take our time. We had this amazing campaign, and we had customers affected by it, so we couldn't take our time.
Yeah.
But it was in the wild, and we saw literal customers around the globe being affected by it. It wasn't with Palo Alto, so it's a different story. So, but it happened.
Few more in the bag.
But basically, it happened a while back, and so we had this really cool story. We were researching, and we took everything. We had all the data, and at some point we decided, you know what? We want to do this more. We want to do this better, and we reached out to some other vendors, and we wanted to share the information.
Kind of
And-
revisit the same research.
Yeah, we wanted to do this, like, we wanted to have better visibility into the data, and we wanted to share the data with them and to get their standpoint on it. So we had some limited visibility from the vendor I was working for, and so we had some limited visibility, and the other vendors we talked to had other visibility into that. And so we did this joint publication, and we said, let's do this together. And we shared the signatures, and we collected data together, and we had this amazing, let's call it geomap or something. And now we have, instead of like only small visibility on the map, now we have this beautiful map and all the different countries and all the different sectors and everything.
Geomapping is always
Yeah,
something
we need to make marketing happen,
Cybersecurity
right?
style.
Yeah.
we need to do this pew map. It's important. And then since we're doing this in collaboration with several vendors, we need to make sure that all the vendors are publishing together.
Right.
And it's important. So we said, okay, you know what? We're going to publish 9 a.m. Eastern time. And all the vendors are synced on it. And then 9 a.m. Eastern time comes, and everyone is publishing together. The only vendor that didn't publish was us, because our marketing forgot, because they were on the West Coast. They didn't wake up.
Time zones.
Yeah, time zones is a
So
problem.
all the rest kind of stole your thunder, I guess.
yeah, and it's like, wait, what just happened? And it's
Okay, so this is a similar case of
it's
publishing
just,
a bit too late, maybe.
it happens.
Yeah,
It
it happens.
It
I guess
happens.
Your stories are a bit similar. So what did you learn from that? I guess you learned not to take your time. Right?
Exactly. Not to take your time, that's the first thing.
And adjust your clock.
And adjust your clock.
And adjust your clock.
And I think I learned from it to make sure that the blog post is automated, not to have a person.
Yeah, not
to
have a
push the
person
button.
with a
Yeah,
finger on the button.
It's more about like automate things.
Yeah. So Sharon, we still want your story about how you tripped yourself.
Yeah, sure. So I have a funny failure story. We're in the vulnerability research business, and we're doing a protocol stack vulnerability research. So we're looking at a lot of scatter-related protocol stacks for example, Modbus or Ethernet IP or other protocol stacks. And we tried to identify kind of problematic patterns in protocol stacks implementations. And we were looking at Modbus protocol stack, and we kind of analyzed the RFC, how it needs to be implemented correctly and what are all the checks that needs to be enforced. And we found a product that did not have one of the checks. So we thought we could easily bypass it in order to create a denial of service condition. But we did not check it. So in SCADA, it's very difficult to obtain or purchase these kind of devices, and we kind of had hard time to emulate the firmware. So we just said to ourselves, okay, it's gonna be fine.
You assumed.
We assumed, exactly, we assumed. So we just assumed to myself.
Compiled.
Yeah, we know the protocol. We researched dozens of similar protocol stacks. We know all the checks, and this check here is missing. So for sure we can bypass it. And we felt very arrogant, and we did not create the POC to reproduce it. So I just our team generated a very thorough report with all the information and screenshots from IDOM and screenshots from the RFC of the protocol. And we sent it to the vendor. And obviously, a couple of days later, the vendors wrote us back, thank you very much for the information. We appreciate your commitment for security, yada, yada, yada. And then we could not reproduce it. Can you share with us the POC? And I was...
Trust me, it's more.
I was...
your setup.
I was very ashamed, I must say. It's a glorious failure, and we discussed it a bit with the vendor. We jumped on a quick Zoom call.
And you understood that your assumptions were...
Yeah, and they explained us they modified a bit the protocol, so they used kind of esoteric flavor of the protocol that did not need this specific check.
Okay.
So because they had other checks in different places.
Understood. And I want to go back to one of the words you said. You said you were a bit arrogant around that. So is arrogance something that you revisited in your postmortem or when you try to learn from the process?
Yeah, of course.
In security research?
Possible.
Never.
No arrogance?
No, so we obviously analyzed all of our processes and procedures because it's really unpleasant feeling that you're feeling full confidence in yourself and you're sending a report to a vendor and then they're telling you they cannot reproduce it. It's very similar to your story, actually. So yeah, definitely.
Okay.
After that, we learned.
I think in general that when we own our failures, when we know that we are the owners, we are to blame. Maybe it's easy to learn something from it. What about cases where someone else, like a third party or someone you are working with, failed you, caused some sort of failure? Eran, let's start with you.
Yeah, I have a good story about that. And I learned from my past mistake, and now I used an unprivileged shell to do the entire thing. So that's a very large AV vendor, European AV vendor, if I may say. And I found two cool local privilege escalation bugs. And I reported that, as usual, responsible disclosure process. They had some hard time reproducing it, but after a week or so, they succeeded. I thought to myself, okay, great. And they said to me, we will give you the CVE when we patch the product out. I was waiting and waiting. And then I see that they patched the product, and I haven't seen any CVEs or any changes in the release notes indicating that they patched the bugs. So I checked if they actually patched the vulnerabilities, and they did. I sent to them an email saying, what happened? Can I have my CVEs, please? And then no response. Another email, even nicer, no response. On the third email, I said, okay, it's not cool. That's not the way to treat you security researchers. And after around 10 minutes or so, I got an email starting with the researcher and ending with legal proceeding. And in the middle, they said to me that I was committed to the bug bounty program, that I had no prior knowledge about it, while reporting. And I signed that I cannot publish anything about the bugs because I received money from them, bounty, which I didn't, and I had no clue that there is such a program. Eventually, I contacted Mitra, the organization that gives new CVEs in cases that the vendors are not playing by the rules, or the vendors are not cannot give you any CVEs because they are not a CNA. And I published about one of the vulnerabilities in a blog. But it can happen. Some vendors are not that nice. So
Not that nice. When you're saying not that nice, you mean that they're usually pulling the legal card.
yeah,
right?
they pull the legal card, especially in cases of bug bounty program, which I realized afterwards. Because if you participate in such a program, sometimes you actually say, I will not disclose the
Right,
information in
correct.
public.
Okay,
But in
so-
here, I just sent an email. I had no clue
So what did you learn from that?
that you need to contact Mitra before that, before anything you do. And that's it. And don't take it too seriously when they threaten about it, because usually it has no merit. The threat has no merit.
I had a similar story to what Ran just described, but I think the lesson learned is a bit different.
Let's hear it.
We published about an exposed platform that we've detected that is just available to the internet, and it has a lot of credentials on it, like Slack, Git, and so on. We've detected around 50 different credentials there. And we published about it. Once again, you want to share it with the community and so on. And one of the companies that we've detected credentials on this platform reached us and say, hey, you said that we got breached. Well, obviously that's not what we said, right? And probably the write-up was not clear enough.
Yeah.
And that's where the lesson learned is a bit different, because I think they just didn't understand, and they were threatened by the technical research that is in front of them. And once again, they used the legal card. Right? They were like, please remove the logo, remove the article, remove the company, do whatever you can to.
So while you were
exclude
talking
that.
about the vulnerability, they were getting it like you are publishing some sort of active breach.
Right, exactly. And you haven't contacted us and so on, which is obviously not the case, because that's the credentials we've detected on the server.
Yeah.
They do not own the server, right? So what we learned from it is to make sure that the text is super clear, and you could explain it not to the most technical researcher like us or like Eran, but it needs to be wider, right? We need someone technical, obviously, to read it, but it doesn't have to be too technical. Otherwise, other people could read it and get lost or scare you.
So I can tell you, just on this specific topic, usually when we publish something, we try to either mention there were no breach, or we have no evidence of an active breach happening. This usually closes that area.
That's good.
Of
One of the things we also added to this publication pipe from this story is to get a review by someone who's not from the research team
Yeah.
to the blog post.
Always have
and
someone
non-technical
from
review.
the marketing and product side review your publication, because we always tend to write in geeky language. We love it.
It's fine.
And I love to write stuff that Eran will enjoy reading.
Yeah.
But
It depends your audience.
Exactly. Although Eran would love to read my blogs, we also need to make sure that the legal people will love to read my blogs.
and also less
and those
technical.
are two different
And usually it's not the case, especially in my case when I report on vendors that I
Exactly.
said.
We always need to make sure that both Eran and the legal person would enjoy this blog and won't sue me.
So Irena, let's hear a story from you about how someone else wronged you.
Wrong.
Oh, people always wrong me.
We're not here to solve all issues.
But I think I don't know if I want to talk about that. If you'll allow me, I think I want to talk about something else.
Sure, go ahead.
You've wronged me. Just kidding. I think one of the main reasons we don't talk about failures is because we're really afraid of the fact that people will point fingers. And every time I fail, I'm afraid that someone will blame me for it. And eventually, either if I'll tweet about it, or if I'll say that I did something wrong at work, then I won't get my bonus. So,
so like-
it's a
like-
problem, right? It's owning up to the failure. It's a problem.
You're talking about consequences.
Exactly. Consequences are a bitch.
Not just naming
It's-
names and pointing fingers, but actual consequences.
You always need to own up what you do. So it's a problem. We need to, this is one of those things. You need to always remember that it's a problem. And this is one of those things that we're afraid of.
Yeah.
And
Could be a bad culture of the organization, maybe, because if you, I would like to work in a company where you could take responsibility even on the bad things that happen, and won't feel that you'll get fired.
I agree with you. I'm not sure it's a cultural thing. I think it's more of it's
personal
not about
feeling.
organizational things.
It's a
I think-
personal feeling.
Exactly. It's more of I think we're all afraid of that, right? It's not about organizational thing. It's you're afraid of it from inherently from you're afraid of it because you're afraid to get fired, or you're afraid that you'll lose followers on Twitter.
Okay, so
or
Irena, I want to challenge you here. You derailed the subject, so I'm going to take it.
I just
take
wronged
advantage
you.
of that. What happens when someone from your team, someone that reports to you, fails? Something very, very serious happens. What is your response? How do you help them get back on track?
So it's very easy. So there are two things that happen. First of all, the question is, how did they fail? So if, for example, it's an external failure, say you come up to me and you say, hey, your employee just screwed something over. No, he didn't. He was perfect. He did everything well. He's perfect. He's the best employee in
Full
the
backup.
universe. Yeah, he'll get my full support.
Okay, so that's the backup you give
Yeah, and then
in front of other areas.
exactly. And I'm not looking for someone to blame. I'll always look for ways to get better. We'll find, like, my employees are the best in the universe. We'll find in closed rooms, we'll figure out what went wrong. We'll figure out, okay, we didn't do this right. The process needs to get fixed. We need to do this, and this better. We need to figure out how to solve the issue that made this problem. Probably wasn't my employee's direct issue, right? It might be that he didn't know how to do something, but then it's my fault. You need to own the problem. It's not your employee's problem,
So
it's
ownership,
your problem.
positive thinking,
And
good
owning
feedback,
up and
And
owning
backup.
up your
and
employee's
backup.
problem.
Definitely backup and try to pull them out of the gutter, because we kind of tend to punish ourselves more than others even punish us, right?
Yeah.
We are the harshest critics of ourselves.
Yeah.
I also think it's management. It's never the small researcher's problem. It's always the management chain.
Like
Yeah,
you need to have a
don't-
proper environment to encourage people to admit their fuck-ups. It's important for people to feel comfortable.
Yeah.
Yeah, it takes a lot of courage to go to your manager and say, hey, I did a mistake, right? Dramatic one.
Failed.
And at the end of the day, you need to own up that even if someone in your team did a mistake, you're responsible for it.
Yeah.
Right?
You need to own up for it. And if they didn't follow up procedure, it's your responsibility
we will
to
own it.
validate and
Yeah.
prove it.
Okay, Sharon, you mentioned before, you said SCADA. And when you say SCADA, or in general, ICS-related vendors, manufacturers, we think of dinosaurs, to be honest. You really think about dinosaurs. How are they responding to vulnerability disclosures? What is the response? Are they actually happy for people trying to break their stuff? How does it go in this weird ecosystem?
Yeah, it's a really good question, actually, because as you said, SCADA, cybersecurity SCADA is something new. SCADA systems have been existed for many years before the the new IT world. And many of these vendors are not familiar with the cybersecurity aspects because in SCADA, you need the devices to run smoothly. So you don't have redundant CPU cycles to burn on checks, cybersecurity checks, because you needed the critical machines to work flawlessly. So in the past, there were no security checks, and there was no concept of cybersecurity in SCADA. No usernames, no passwords, no binary exploitation mitigations, nothing. So all of these concepts are kind of new to the vendors. And they're trying to keep up with the modern cybersecurity era. So the big vendors in the SCADA world are quite familiar now with the modern cybersecurity aspects, and they do have a very organized procedures for reporting of vulnerability, having a very organized procedures for product security, how to receive reports from emails.
So they're familiar with it more because of active disclosures or because the industry itself is growing, educating itself? What is changing there?
Exactly. So I think because new players, new cybersecurity defense companies like ours, Clarity, came into the world and started to check these devices and report on the vulnerabilities on these devices, these vendors started to learn, and we kind of educated the entire market, and I think we're improving it as a community. We're improving the cybersecurity market in the SCADA world and domains, and now vendors are much more appreciating cybersecurity researchers poking at their devices.
So you're saying basically there was a gap or there is a gap, but we're quickly closing that?
Yeah,
because that's awesome to hear.
Exactly. We're definitely closing the gap in cybersecurity research and the acceptance of SCADA vendors for the security reports and vulnerabilities in their products. And we can see that because in, I think, the past 1 or 2 years, we've seen many new vendors implementing new cybersecurity procedures for receiving research reports and acting upon it. So improving the security of their products, issuing advisories, communicating this transparently to their users and customers. So we are seeing a great improvement.
That's awesome. That's really awesome, and actually, I'm really happy to hear that.
Yeah.
I was under the impression it is happening, but it sounds better when you say that, when you actually handle that on a daily basis. Eran, I'm going back to you because before this panel, we kind of discussed what kind of talks are relevant for the Intent Summit or other technical or more technical, less technical summits and conferences. Is it interesting for you to attend not only as a participant, but someone who will come and visit a panel or a talk about failures?
Yeah, surely. For instance,
that was a quick answer.
Yeah, because it's a definite yes. For instance, a lot in the vulnerability research business, you use fuzzing nowadays more than ever to find bugs. And while you do a project that you look for new bugs and you use a fuzzer, one of the hardest things is actually to build the environment and to configure it to work properly. So even if you had the best mindset to where to look bugs, you understand the protocol, the structure, the driver, or whatever, you sometimes have some hard times building the environment correctly. And if I hear a talk about someone that struggled for 2-3 months to actually build the environment, and from my own personal experience, I went through those hardships as well. And I thought to myself, actually, that maybe that's not the way. It's too difficult. I should quit. And I think that if people hear other people quitting as well, it's okay, because it makes them feel better and more encouraged to continue and work harder in those elements. Also, we should share more of our, I think, the way we do things and not just the end goal things, not just like the primitives, the exploits that we do, but more about the research mindset that we had along the way to achieve those things.
Yeah, okay. So that's very, very interesting. I'm starting to think that maybe you go to these talks, to see other people are frustrated as well.
It's okay, and
Yeah,
it's good.
no, I agree. It's
Part of being a
definitely-
community. Again, it's not only the funding.
Being a security researcher, especially a vulnerability researcher, is a difficult job because of the emotional aspects of that as well. You break your head against a wall for could be for a month or so, and then you have a small miracle, you discover something, and you go for it with full power, and then you discover it's nothing. Or the other way around. So it's very important to understand that other people have those hardships as well. It's not just you. You're not alone in the world. Everyone have it.
It's definitely true. It's been talked a lot recently that being in security research is sometimes be very frustrating and very. A lot of people feel the mental stress of it.
Demanding.
It's very demanding.
To
And
find something, to find a vulnerability, but sometimes it's just not there.
Yeah, it's and it's research. It's at the end of the day, 90% of research is failure, and you have this hypothesis that you will end up winning.
Yeah, so
But
we
you
can
will-
never have KPIs on the findings because you can easily do a 3 months research that ends with a no.
No.
Right?
The way we
Agree.
deal with this, by the way, it's a really good topic because it's hard to define KPIs for success in vulnerability research. So what we do before defining the KPIs for finding a vulnerability, because maybe it's not there, what we're doing is defining the KPIs for covering the attack surface. So the first thing we're trying to do is we're trying to go over the product, see how the product is working on a normal basis, and then we're trying to cover the attack vectors, how you communicate with it, whether it's a network, a file input, what kind of interactions you have with this product or device. And only then we're trying to dig inside and try to uncover the unseen attack surface. And only once we have a few days or weeks of research, only then we're trying to define the KPIs for finding a vulnerability.
Okay, so I think that I already have the topic for the panel of next year because all of you somehow included the disclosure process or the findings in that. A question that comes from our audience at the moment, another one is, when we look at the response of the vendors or our targets, let's call it, we are very dependent on their replies, on the way that they actually talk to us and communicate with us. What do we do with those who just go completely silent? I don't want you to mention any names, obviously, in your response, but what do we do with those who go silence? Even when sometimes the findings are extremely severe. I don't know, SCADA can be life-threatening.
Yeah, we're
right?
working very closely with ICS CERT, which is the CERT organizations dealing with ICS equipment, and they're great. We're just communicating, and they're helping us with coordinating all the vulnerability disclosures, and the conversation with them is just open and
So that's around ICS. What
Yeah.
about others? Ari, do you have any experience
in malware
with
analysis-
silent disclosures?
Yeah, so sometimes the victims, they just do not answer. I mean, what can you do? You try to reach them via email or their website or law enforcement, or even national certs. But if they do not answer, then there's nothing. We're doing the best, right, to reach them. We're trying to use even personal connections and such. But sometimes they don't pick up the phone or email or fax even.
So, Eran, you're nodding. Is it
Yeah,
something that
I
happens to-
agree, and I actually can tell a recent story about that I found some nice bugs in a PCI maker company, who shall continue to be nameless until 1 week from now, maybe.
Okay.
And the
Nice,
way
nice plugin. Go ahead.
the way I got to them eventually was through 2 different hoops in the chain. From Microsoft, because they had some drivers that are signed by Microsoft, and then by another company. And then the entire conversation with them was very, very difficult and it took them more than 1 year to actually to patch the bugs.
But at least they answered.
And
Eventually
in
they
the end, they answer. But in some other occasions, I said to myself, okay, I'm trying my best. I send them every email that I can. But if they do not respond, I'm telling them, okay, I'll publish it. I disclose it in public. And if they do not respond, then you've done your best. And that's perfectly fine for me if I done my best to publish my findings.
Okay, Irena, they don't respond. What do you do? Zero
I
communication.
don't do vulnerability research.
Oh, right,
I
right.
don't have an opinion, thank
Right.
God. I don't need to have this problem, so.
Ari, zero response. What do you do?
Yeah, so again, with the malware analysis and threats, sometimes you do detect victims that are dealing with an attack at the moment. And besides, try to reach them any way you can through, again, law enforcement or national certs. That's the best you can do. We even send some messages on LinkedIn. But
By the way, big players in the market like ZDI and Project Zero of Google have a very concrete, let's say, deadline.
90-day policy.
90 days,
Yeah.
and that's it.
Yeah.
So 90 days, you answer, you don't answer, it's out.
They
yeah,
even
but you
do
want to
it
be nice, right?
You want to be nice. We're giving much.
They even
much
do
more
it to
time for
large
the
vendors as well, not just to small vendors. Like Project Zero doesn't care less to publish bugs.
I think that the 90-day rule is kind of the rule of thumb currently in the industry, right? Unless they actually give you an explicit okay to go before that.
Yeah, so what we're trying to do is we're first trying to communicate with the vendor. If they don't answer, we try again via email. If they don't answer, we're trying to approach ICS CERT, and then we're working and coordinating everything through ICS CERT.
Okay, so we are almost out of time. I'm going to ask you for a quick answer for the next question. Let's see if we can have some take-home message of how to actually improve the culture of sharing all these failures, all these screw-ups, fuck-ups, whatever you want to call them, but when something does not succeed, how do we do that? Although we might put them in the spotlight and there might be, as you said, Irena, consequences. So Sharon, start with your idea.
I definitely think that we should, when we're publishing our research, we should definitely talk about the dead ends, the path that went nowhere, and mention them in order to inspire other people not to go there or to think of other creative ways to circumvent these paths.
Okay.
yeah, I very much agree with Sharon. I think that we should also do post-mortem to understand what went well in this research process, what can be improved, and by that, do better next time.
Eran, your quick review?
Yeah, I agree, and I think that conferences should also include those kind of talks about failures along the way, and companies need to reward their employees based on the effort and not just the end result.
And Irena, your final sentence here.
I think that we should adopt the Nike motto, just do it. All of us, both as companies and as security researchers, let's use our Twitter power and just do it. Just share our failures on Twitter.
Excellent, sounds good, and we're going to just do it. So thank you so much for this eye-opening discussion. That was really great. I hope every one of you will continue succeeding and failing every now and then. Thank you, our audience, for joining us. Enjoy the rest of the sessions. We'll see you in a very, very similar panel next year. Thanks.
Thanks.
Bye-bye.